in this video, I'm going to be talking about tuples and sets. So what is a tuple and what is a set? Well, both of them are just types of data structures. All right. So tuples and sets are types of data structures, just like lists and dictionaries, but they have kind of different functionalities with the ways you can use them, and they also have different uses. So first things first, I'm going to be talking about a tuple. I'm going to create a variable called tuple example and set that equal to a tuple. So how's a tuple initialized? It's made by regular parentheses. A normal list uses these little brackets, but a tuple uses parentheses. And if you want to put information in a tuple, you can put it in the same way that you would put it into a list. You can put integers, you can put strings, you can really put whatever you want. Let's go ahead and put the string Jitty. So this right here is a tuple, and it's created using these parentheses. Another way you can actually create a tuple is by making a, flue of information, just a bunch of information separated by commas without the parentheses. This is still a tuple. It does essentially the same thing as this. So a tuple has a few special properties. It cannot be changed, but it can still be indexed. So those are two main things that you should know. So what do I mean by it cannot be changed? Normally, if you have a list, let's go ahead and create a list example, and let's say this list was full of 1, 2, and 3. If you wanted to add a value onto the list, you can write down list ex dot append, and then append something new into it, like ooh. All right, this works. You can append a new value into the list, and you can change the values inside the list. Well, the thing about a tuple is that there is no append. So let's say you try to append 89, the string 89. You're going to get an error. The reason why is because tuples do not have the append method. You cannot change tuples. So tuples, once you create them, they're like that for the entire program. You cannot change the order, and you cannot add values or remove values into it. So if I tried to, let's say, remove, what if I wanted to remove the number 5 from here, right? If I want to dot remove, still wouldn't work. Tuple does not have the attribute remove. So you cannot remove values, you cannot add values. So no removing, no adding, and no changing. So you can't even change the order of the values as well, or even change the values. So let's say we wanted to change the first value of the tuple, and we can remove the list example now. Let's say we want to change the first value of the tuple with index 0, and let's go ahead and set it to 9. All right, this still doesn't work because you cannot change the first index to 9. You can't change any of the values in a tuple for that matter, and I've been repeating that a lot. So when is this useful? Well, in like beginner programs, you're not going to really use it too much. You can mostly just use lists. Anything a tuple can do, a list can do. But normally you would use tuples for, it says right here on Google, coordinates, RGB colors, and database keys. All right, whatever the database keys means. I mean, like coordinates is pretty self-explanatory. You wouldn't want coordinates to change on the world unless you're changing coordinate systems, which I don't think humans are going to do anytime soon. So that's a pretty good example of when you would use a tuple. A couple more things that you should know about tuples is that there's multiple ways to make them. So I showed you that you can use a parentheses or without the parentheses, just as long as you put the bunch of commas there, it works. All right. This is still a tuple. Now, you can actually create another tuple, so tuple ex number 2. You can create a tuple by putting the number 8 and then putting a comma after it. Now, the reason why this comma is important is because if you say tuple ex and you put these parentheses around the 8, this is simply saved as an integer. So if I were to print the type of data that tuple ex2 is, you're going to see that this is just an integer. So this variable is simply an integer. If you want this to be a tuple, you need to put the comma right after the 8. And this is how you save a single number inside of a tuple. All right. So if you want a single number inside of a tuple, then you need to put the parentheses and just a comma after the value in the parentheses that you want to save as a tuple. And as you can tell, the type is now a tuple after I put the comma. So I've previously mentioned that tuples can be indexed, and I already tried to show you, right? Tuple example index 0 is equal to 9, and you couldn't change index 0. But here's the thing: you could still access the value at that point. So if you wanted to print out, let's say, tuple index 0, this still works, right? Tuples have indices just like lists. The indices always start at 0, so this right here is index 0, index 1, index 2, and index 3. If I wanted to print out number 2, this right here is index 4 of the tuple, so I write down print tuple 4. This still works. If I wanted to do math, let's say tuple 4 plus 6, right, it would be 2, since tuple 4 is the integer 2, and 2 plus 6 is 8, so we would print out 8. So you can still do values. You can still use the values inside of a tuple. You can still print them and string concatenate them if you want, if you have strings inside of your tuple. But you can't change any values or remove or whatever. All right, just these rules. They are set in stone. The tuples are set in stone. All right. And here's the thing about indices. You can have the index method for tuples. So in a previous video about lists, I talked about the index method. So if you put index, right? So if we were to print this out, print the tuple index with something inside of the index. Let's say we want to print the index of the number 6, right? This still works. All right. So number 2, index 2 is the index of the number 6 in this tuple. And if you want to write down the index of Jitty, we can assume that this is, let's say, 0, 1, 2, 3, 4, 5. So Jitty's at index 5. Print out 5. So index still works. How about count? Well, count is another method that you could use when it comes to tuples. So let's say that there's multiple 2s inside of this. Let's say you can put multiple 2s. Let's put multiple 6s. 6, 7. And multiple 1s. So if you want to count the amount of 2s there are in here, there's 1, 2, 3, 4, 5. There's 5 2s, and you'll print out 5. So tuple.count and tuple.index still works. You can also, let's try it out with 1. So there's 1, 2, 3, 4 1s inside of this tuple. So we print out 4. So .count just tells you the amount of instances of your little input you put inside of .count in the tuple. There are. I write down Jitty here with a capital J. Still works. There's just one instance of Jitty. If I put a bunch of random letters, there's 0 instances. All right, it's not going to give you an error. Basically, if there's nothing inside of the tuple that matches your input, then you'll just get a 0 for count. Now, the last thing I would like to talk about for tuples is that you could store lists inside of them. So, although the tuple itself is unchangeable, the lists, dictionaries, or sets inside the tuples are changeable. So let's say you wanted to access the list at index 0 of the tuple, right? Since the list is the first value of the tuple, or this first piece of data you have in this tuple, and you wanted to change the number 6 here. So if you wanted to change the number 6, 6 is index 2 of this list, since it's the third value of the list. And you can set it to 9, let's say. So if we were to print out the tuple now, before and after changing the list inside the tuple, this would still work, right? 6 turned to 9. You can also still append. So if you want to refer to the list, you would have tuple 0. And you can append some new value into the list, right? So the values or the tuple itself is unchangeable. But if you have something that can be changed inside a tuple, for example, a list or a hash map, which is just another way to say dictionary, then you can add keys and values to those dictionaries, or you can append or remove values of those lists inside the tuple itself. The next data structure I would like to talk about is a set. So let's go ahead and create a set. And sets are created using curly braces. Now, you might be wondering, aren't these for dictionaries? Well, sets are still made with curly braces, but you simply don't have those keys and values like you would in dictionaries. With sets, you have just values. So let's say you have 5, 5, 3, 2, 4, and 1. And I'm going to point this out specifically right now, but there's 2 instances of 3 here. So when I print out set, take a look at what happens. The 3 actually disappears, and the numbers appear to be ordered. So the duplicate 3 actually appears to disappear, right? And the numbers appear to look ordered. Now, there's a reason why I'm saying appear. Technically, the duplicates are removed, but the reason why these appear to be ordered is just what Python does under the hood. It's not technically ordering them in the sense of how you would order numbers, and this illusion actually breaks when you use negative numbers. So notice how the -7 and the -2, they aren't really ordered properly, right? -2 should be less than 1, -7 should be less than -2. But that's besides the point. I'll actually show you another example of that, but let's create another set for now. So another, that's bad. Wrong letter there. But another set, all right, would be 1, 100, 4, 50, 4, and 2. And when we print this, you get another set, all right? These numbers are also not ordered, right? 1, 2, 50, 100, and 4 clearly are not ordered. So sets aren't actually ordering things. They do, in fact, remove duplicates automatically, but they don't really order things in the sense that you think they would. Now, I'll turn this into a list right now. And the reason why I'm doing this is just so, quick example, I just want to show you that you can actually typecast a list into a set. Right, so this right here is still a set. Before it was a list, it was an iterable, right? An iterable that's a list. And when you typecast it with set, it becomes a set. Now here's the thing, there's not really a point in doing this. You can simply just write down the curly braces from the beginning. But if you had, let's say, a variable another set, ex, this is just a list for now, and you were to change this to a set, you can simply write down set with the variable name of the previous list, and this turns it now into a set. All right, and as you can tell with the curly little braces at the end, we know that this is a set. Another set is a set. Now, the thing about sets is that, yes, you can change their values. Unlike a tuple, you can't change values or, switch things around or add or remove anything. A set, you can do so. So I'll show you how right now. Let's go ahead and keep set example. And let's go ahead and write down set ex dot add. So you're not using append, you're using dot add. And let's go ahead and add the number 8. So if we add the number 8, you're going to realize once we print this out, 8 appears. We can actually remove the negative numbers for now, since you get the point that these don't actually order things. They appear to order things in certain cases. But add, and we added 8 here. All right. Now here's the thing. What if we added 2? Right? I mentioned that sets don't have any duplicates, right? So if we add 2 and there's already 2 in the set, what will happen? Well, in fact, nothing will happen. You will not get a duplicate. Sets automatically remove duplicates. And this applies to strings as well. So if we write down Jitty and Jitty, right? It's going to remove the Jitty duplicate. All right, I typed down Jitty twice. Technically, it's a duplicate. Jitty not duplicated, right, when we print it out. So the little removing duplicates is not exclusive to integers. You can also remove values. So when we remove, let's say we wanted to remove, say we wanted to print the set before removing and then after removing. Let's say we remove the number 3. When we print this out, you'll notice that before removing we have 1, 2, 3, 4, 5, and then after removing 3 specifically, the 3 is gone. So remove can remove, right? But here's the thing. If you put down a number that's not actually in the set, you're going to get an error. All right? And this is what you see here. You're going to get an error because 9 is not inside the set. How are you going to remove it if it's not inside? Well, another thing that you can use dot discard. And dot discard simply does nothing if you don't remove it. So I suggest that you use .discard. If you don't want an error, they essentially do the same thing. Remove and discard do the same thing, right? Both the methods remove something, but discard just doesn't give you the error if you type something that's not inside the set, or if you try to remove something that's not inside the set. But here's a large downside for sets. So let's go ahead and remove this .discard. And this large downside comes to the fact that sets are completely unordered. They do not have indices. So with the tuple, that's ordered, right? You have indices, correct? Sets, womp womp, they don't have indices. So if you were trying to print out set EX at index 0, right, which is the number, supposed number 5 in this case, what's going to happen? You're going to get an error. Sets don't have indices. You simply just can't do anything with them. Let's say you want to print out number 3. Yeah, there it is. This is just going to get an error. Sets don't have indices. So there's a little weakness about it. But of course, just use lists, right? If you want indices, why would you even use a set in the first place? Now, there's a pretty big strength when it comes to sets. Although it doesn't have indices, these sets can do things that Venn diagrams can do. What am I talking about? What am I talking about for these Venn diagrams, right? So with Venn diagrams, you have a side, let's say you have side A, right? You have the center, right? And then you have side B. And the center is the intersection between the set of side A and the set of side B. So imagine these two circles, and these two circles intersect at the very center. And the separate center represents some intersection. Now, what do I mean by this, right? Well, you can use Venn diagram things with sets, okay? So let's go ahead and create a set 6, 7, 2, 4, and 3, all right? And we can actually remove these duplicates for 3 since I'm guessing you guys get the point by now. But if we wanted to print the union of these two sets, so just the entire Venn diagram itself, you can write down A with this line in the middle, B. And A and B are simply the variable names of the two sets you want to combine. So the union of these two sets is 1, 2, 3, 4, 5, 6, 7, right? And keep in mind, I wrote down 2 multiple times in these two sets on purpose, and 3 multiple times on purpose, because the union actually excludes duplicates. So union kind of combines these two sets together. It combines the two sets together, and it removes all the duplicates, and you get this new set, right? And you can actually assign this to a variable. So let's say union set, and you can actually assign this to a variable, right? And if you want to print out union set, you would get this. So union simply combines the sets and remove all the duplicates. It's technically the entire Venn diagram, right? You combine both the sets in the Venn diagram, and then you get a union. Now, another thing that you can do is, let's go ahead and comment this out for you guys, a intersection set. So intersection, and let's go ahead and print out the intersection set. So what's the intersection? Well, the intersection between two sets is what happens at the center of the Venn diagram, right? The intersection between the two circles of the Venn diagram. If you don't know what a Venn diagram is, you were missing out on some couple things in 3rd grade. But the intersection is basically the values that are similar in both sets. So the values that are similar are 3 and 2, correct? These are the duplicate values that we have in both the sets. And if I were to print out the intersection set, and I need to change this symbol, of course, this stands for union. But if I were to print out the intersection set marked by this ampersand here, I would get 2, 3, and 4 as well. I did not even see that. So intersection gives you the common values between these two sets. And you might be wondering why this is useful. It's probably useful for a couple projects out there. All right. So side A and side B intersected, or technically set A and set B, when they intersect, they have common values. And that common values would be marked by the center of this Venn diagram, right? Or you can put the common values in the center of the Venn diagram. But intersection tells you the values that are common between the two sets. Let's go ahead and comment that out. And the next thing I would like to talk about is the difference. So difference. And difference is marked by a subtraction. So we write down difference set, and we were to print this out, we actually only get 1 in 5 for this. Well, the reason why is because difference basically gives you the values of the two sets where they don't have shared values. So what do I mean by this? Actually, I probably said that wrong. There was a lot of garble jarble. Whatever. I probably said that wrong. But I'm going to clarify what I said right now. But difference gives you the values of the first set you put in here that are exclusive to this set. So the values of the first set you put right on the left side of this minus symbol, it gives you the values that are exclusive to the set. So the values that they don't share and the values that are in the other set to the right are completely excluded from this different set. So what do I mean by this? Well, here's the thing. In another set, we have 6, 7, 2, 4, and 3. And in set EX, example, we have 5, 3, 2, 4, and 1. Here's the thing. Set EX and another set share the values 3, 2, and 4, correct? But 1 and 5 are exclusive to set EX, or the first set. 1 and 5 do not exist in the other set. Therefore, the difference is what doesn't exist in the other set, but exists in this set. And you get 1 and 5. Now, the order in which you write this actually matters. All right. So the left one is what actually is the set that you get left over. So another set minus set EX will give us different values. 6 and 7. 6, 7. Okay. Terrible meme. I'm not going to say it ever again. But 6, 7 is the values that are exclusive to the left set you put. So the left set meaning the left of the minus sign. So the values that are exclusive to another set will be saved in the new variable, which is 6, 7. Since 6, 7 don't exist in the other set, these are the values that are exclusive to this. Therefore, this is the result of our difference. Now, there's one more thing I would like to mention about sets, is that sets have more methods other than the ones I showed you, right? And you can search these up, and the reason why I'm saying search them up, it might sound like I'm lazy, but there's just so many built-in functions and methods to cover that, and a lot of them are pretty simple to understand that I can't really talk about all of them in one video. So dot clear, so pretty self-explanatory. It clears all the it clears the entire list, right? You just get an empty set here. But another thing that I would like you to know is that, remember how I put down negative numbers here and it didn't work before? All right, so negative numbers actually aren't sorted. Well, you can simply use the sorted function. And if you put sorted and then the variable of the set inside of it, it actually orders the negative numbers for you. Now, the issue with this is that it actually turns it into a list, right? See how we have brackets now here? This is no longer a set, it's a list. And if we were to actually print out the type of the sorted set, we would get type list, right? So that's just the last thing I wanted to cover. If you have any questions, put it in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.